Welcome to The Explainer. Today, we're going to challenge what you probably learned about integration.
All right, let's kick things off with a pretty bold claim, one that might just surprise you.
And look, this isn't just a wild claim. It's based on what real calculus students actually remember.
So, when you think integration, what comes to mind? For most of us, it's one of two things.
Yeah, usually it's area under a curve or the opposite of a derivative. But what about that third one?
What's really interesting is how these different ideas actually perform on new, real-world problems.
Turns out, if you only think in terms of area or antiderivatives, you get stuck. A lot. So what's the better way? Let's dive into the powerful idea that just works.
It boils down to a super simple three-step process. Chop, multiply, and add. That's really it.
See, the whole idea is that for a teeny tiny slice, a changing value is basically constant.
Okay, theory's great, but let's make this real. Think about drawing back a bow and arrow. You know that force isn't constant, right? It gets harder. So, how do you find the total energy?
Well, we can start by just measuring the force at a bunch of small, even steps. And now we use our process. Chop the pole into pieces, multiply force and distance, and add them up. And boom, there's the total energy stored in the bow, all calculated piece by tiny piece. And get this, we just did integration. No scary symbols, no antiderivatives, just simple math.
Okay, let's connect this simple idea back to the formal math you might have seen in class.
That big, swooshy integral sign, it's just a stretched out S for sum. It means add it all up.
And that dx at the end, that's just one of our tiny little chopped up pieces. Simple as that. So the secret was right there in the symbols all along. Sum up the little products.
So what's the big deal? Well, this isn't just about math problems. It actually changes how you see things. It turns integration from a weird calculation into a tool for understanding the world all around you.
So now that you have this new lens, what problems are you going to solve with it?